There is another command that is NEG. The NEG instruction is basically the negation. It takes the 2's complement of the value that is passed against this instruction. For example, the syntax of this instruction, that this instruction only requires one operand, and the negation or 2's complement of this operand will be calculated, and the answer will be stored again in that register. So basically, if I take the example of NEGAX, basically that command will execute and perform the 2's complement of AX, and the answer will be stored, and the 2's complemented answer will be stored in AX register. Then we move forward to the multiplication command. The short form of this instruction is MUL. MUL stands for multiplication. Now there are two type of multiplication. One is 8 cross 8, or second option is 16 cross 16. So we can perform 8-bit multiply by 8-bit multiplication, as well as 16 multiplication 16-bit. If I talk about individually, I take an example of 8-bit number and I multiply this 8-bit number with another 8-bit number. The answer can be of 32-bit. So this instruction is again a one operand instruction, that multiplication need only one operand. So for the multiplication we need at least two operands. So where will be the first operand? Always remember that in case of multiplication, the first operand should be stored in AL register if you are multiplying two 8-bit numbers. For example, if I want to multiply two 8-bit numbers, I need to place one 8-bit number in the AL register, and second number will be passed against the multiplication command. For example, here you can see that move AL, 230, one 8-bit number is stored in AL register, and second 8-bit number is stored in BL register. And then there is a command MUL space BL. Basically, this command will multiply the 8-bit of AL with the 8 bits of BL. Now the answer can be of 16 bits, so that 16-bit answer will be stored in AX register. In these cases, in the case of multiplication and division, you are bound to find the answer from that registers only, and you need to place one operand in specific register. In case of 8-bit multiplication, the first operand will always be in the AL, and second operand can be in any general purpose register. And similarly, after the execution of multiplication and addition, the answer will be found in AX register in case of 8-bit multiplication. Then multiplication command can also multiply two 16-bit number as well. In that case, you need to place your first 16-bit number in AX register instead of AL register, and second can be placed in any general purpose register, and that second operand should be written after the multiplication command. For example, if you see that move AX, 22330, first 16-bit value will be stored in AX, then this second command, the second value will be placed in BX, and then there is a command MULBX. In that case, the 16-bit of BX register will multiply with the 16-bit of AX register. Now if you multiply 16-bit with another 16-bit, the answer can be of 32-bit, whereas the capacity of AX register is only 16-bit. So basically your answer will be stored in such a way that first 16 bits will be stored in AX register and other 16 bits will be stored in DX register. So here you can see that your most significant 16 bit will be stored in DX register and your least significant 16 bits will be stored in AX register. So this is in case of multiplication command, there is a restriction that you need to place your first operand in AL in case of 8-bit and in AX in case of 16-bit multiplication, and the answer will be at the location of AX in case of 16-bit in case of 8-bit multiplication, whereas in case of 16-bit multiplication the answer will be found at AX and DX. First 16-bit will be found at AX, and second, most significant 16-bit will be found at DX register. So this is the must condition. You need to memorize or remember that register, that you need to place the values in specific register in case of multiplication, and you will be finding the answers again in that specific register for multiplication. Similarly, there will be constraints for division as well.